today? I hope you're quite fine. I am fine too. Welcome to our today's lesson. It's a mathematics lesson on fractions. We are going to look at 7 areas under fractions. The first one will be proper fractions, improper fractions, mixed fractions, equivalent fractions, recurring decimals, BODMAS, and standard form. Welcome and enjoy the lesson. Now let us begin with proper fractions. Now a proper fraction, and before we go to the proper fraction, let's first look at a fraction. A fraction in the form of A over B means that A is the numerator while B is the denominator. Now, in a fraction, B can never be equal to 0. It can never be equal to 0 because it will mean that A divided by B is equal to undefined, a number which we cannot define. Therefore, the denominator of a fraction can never be equal to 0. So B can never be equal to 0. Now from there, let's move on to the proper fractions. Now, if you have a fraction in the form of 3 over 4, for example. Now, of course, we know 3 represents the numerator, while 4 represents the denominator. Now, whenever you have a fraction in which the numerator is less than the denominator, then such kind of a fraction is called a proper fraction. So, numerator being less than denominator. Then that is a proper fraction. Now we have some other cases whereby the opposite is true, and that is what we are going to look at next. For example, if you have a fraction like, and that is part 3, improper fractions. So, if you have a fraction like 6 over 5. Now, of course, 6 is the numerator, while 5 is the denominator. So, whenever in a fraction, the numerator is greater than the denominator, then such kind of a fraction is called an improper fraction. Now, next thing we are going to look at is an improper fraction can be simplified. For example, our 6 over 5 can be simplified to a whole number 1, then 1 over 5. By doing so, we come up with another name, mixed fractions. A mixed fraction is a fraction which has both whole numbers and fractions. For example, our 6 over 5. It is the same as 1 and 1 over 5. So that is a mixed fraction. From there, we move on to equivalent fractions. Now, under equivalent fractions, here is a case whereby we have a fraction like 6 over 8. If we multiply both the numerator and the denominator with the same number, for example, if we multiply these two by 4, then we shall have another fraction which will be 24 over 32. We can as well divide these two numbers by the same number, like divide by 2, divide by 2, and we will end up with another fraction which is going to be equal to 3 over 4. Now, 3 over 4, 6 over 8, and 24 over 32 are equal. So, multiplying a fraction, both the numerator and denominator with the same constant, will end up giving you an equivalent fraction. So, all these fractions here are equal. That is about equivalent fractions. Now, we move on to how do we compare fractions? Now, we get to know that fractions with the same denominator, it's very easy to tell which one is bigger than the other. So this is still under equivalence. So if we have a fraction like 5 over 12 and 7 over 12, which one of these two fractions is bigger than the other? Now, whenever the denominator is the same, then you just pick the one whose numerator is bigger. So we can say 7 over 12 is greater than 5 over 12. Now, what if you are given fractions which do not have the same denominator? How do you go about it to tell which one is bigger than the other? Now, this is how you go about it. Now, for example, we have 4 over 5, a quarter, 3 over 4. And you are told to tell which one among these fractions is greater. Or you may be told, arrange these fractions in ascending order. Now, this is what you do in such a situation. You first of all find the LCM of the fractions. Looking at 2, 5, 4, 4, the LCM will be 20. You put them under the same denominator. Then you compare the value. So, 20 divided by 2 is 10. Times 1 is 10. 20 divided by 5 is 4. Times 4 is going to be 16. 20 divided by 4 is 5. Times 1 is going to be equal to 5. Then 20 divided by 4 is 5 again. Times 3 is equal to 15. Looking at these values here now, you can tell which fraction was bigger than the other, because 10 over 20 represents a half. So, the first one, which is a half, will be represented by 10 over 20. 4 over 5 will be represented by 16 over 20. Now 1 over 4 will be represented by 5 over 20. And then finally 3 over 4 will be represented by 15 over 20. So to arrange these fractions in order, ascending order means starting with the smallest to the largest. Then we shall look at these values. I believe 5 over 20 is the smallest, so 1 over 4 is the smallest, followed by 10 over 20, which is a half, followed by 15 over 20, which is 3/4, then followed by 4 over 5, which is, 16 over 20, which is 4 over 5. That way, we have arranged our fractions in ascending order. So basically, in summary, if you want to compare fractions, put them under the same denominator, and then do like the way we do when we are adding fractions, like we are summing them up. then check the numbers corresponding to the different fractions, and you can be able to arrange them in ascending order or in descending order, or comparing two fractions or more. So these ones are more. Now the ones we started with were two fractions with the same denominator. So all the time ensure the denominator is the same, and then you will be able to work it out. Now from there, we move on to recurring decimals. Now, sometimes we have decimals which look like this. Okay, as in we are looking at recurring decimals and how to change them to fractions. Because remember, we are under the topic of fractions. So recurring decimals are decimals which might look like 1.3333. You realize that in this decimal, the 3 repeats itself many times up to the end. So what do we do about it? We rewrite it as 1.3 and put a dot above the 3. That tells you that in this case, our 3 is recurring. Now, you could also have a recurring decimal which looks like this, 6.7676. Now, in this case, which two numbers are recurring? 7 and 6. 7 and 6. So this one can be rewritten as 6.76, and then you put the dots on the 2. Now we can also have a different scenario whereby we have like 2.025, and so on and so forth. What is happening here is 025 is recurring. It's a recurring decimal. In such a case, we normally write it as 2.025. Then the decimal will be above 5 and above, not the decimal, sorry, the dot will be above 5 and above 0. We don't need to place it on top of 2, because when the 2, this one and this one have the dots, this one means the 3. The 3 are recurring. Now, how do we convert these recurring decimals to fractions? So, converting recurring decimals to fractions. And we begin with our 1.3. Okay, normally, okay, so it's still okay because we know it implies 1.3 with a dot. So when you have 1.3 with a dot on top of 3, it means a number which looks like this, whereby the number 3 is recurring. So this is how we go about solving it. We let a number r be equal to this our number, which is 1.3333. Then we go multiplying this number by multiples of 10 until that point whereby we shall get a number which can eliminate that part which has the decimals. So for example, the first multiple of 10 is 10r. 10r will be equal to, it's like times 10. So move one step. So the decimal will be at 13.333. Now you look at these numbers on the right side of the decimal. Are they the same now? Yes. So we can eliminate that part by subtraction. So we subtract this value which is bigger. We subtract the smaller value from the bigger value. So it's like taking equation number 2 and we subtract equation 1 from it. So here it is like 10r minus r is equals to this one, which is 13.333 minus 1.333. And this is going to give us 12, just 12. And on this side, we have 9r. So 9r is equals to 12. So if 9r equals to 12, we can divide both sides by 9 by 9. So that our r in form of a decimal, it's going to be equal to 1/3/9. So that way we have converted our recurring decimal to a fraction. Now let's try another one. Let's try 6.76 with 2 dots above 7 and above 6, like that. So the first thing is to note that this number is going to be 6.767676, like that, with some dots. Dots means that number continues to recur like that. So the first step, as I've told you, is let letter r be equal to 6.67676. Multiples of 10. 10r equals to 66.7676. If you look at this number on the right of the decimal and the other, can they eliminate each other by subtraction? No, there will still be something. And our aim is to eliminate that section of the decimal point. So we move to the next multiple of 10, which is 100r. It's going to be equal to, move the decimal another one step, 667.676. Can this eliminate this? No. This eliminate this? Yes. Equation 1 and equation 3 can help us achieve our objective of eliminating that part of the decimal. So we shall take r and 100r and say 100r minus r is equals to 667.676 minus 6.676, as they recur like that. So this is going to give us a 0 on that side. So here the number is going to be 7 minus 6 is 1. So 661. And on this side is 100r minus r is 99r. Divide by 99. Divide by 99. So our r is going to be equal to 661 over 99. Let's see the fraction using our calculator. 661 divided by 99 is equal to 667 over 99. Yeah, so that is how we convert recurring decimals to fractions. Now let's move on to BODMAS, which stands for brackets of division, multiplication, addition, and subtraction. Now I am sure everybody here has heard of BODMAS before. So let's just apply it in a question. Most of these questions are usually found in paper 1 of KCSE questions about the use of BODMAS in solving fractions. For example, in this particular question we are told, without using a calculator, evaluate. So here we need to use BODMAS, and BODMAS stands for brackets. Do we have a bracket in this question? Yes, we do. So let's work out the part that has the bracket first. So we shall have 7 over 18 of 3 over 5 is like 5 times 3 is 15 plus 3 is 18 over 5. So when we multiply those two, because of it's just multiplication, then we shall get 7 over 5. Now let's move on to the second, which is division. Actually, this was brackets together with off. So we have dealt with both. Now we move on to division. So we have 2 over 5 dividing the answer we got from this bracket. So we shall say 2 over 5 divided by 7 over 5. And we know whenever there is a division in fractions, we usually change the sign to multiplication and take the reciprocal of one of the fractions. For example, if we take 2 over 5, then the other one will be times 5 over 7 is equals to, these two will cancel out so that we remain with 2 over 7. Then we have multiplication, which is not there, but we have addition, which is here. So we shall say 3 over 4, add whatever we got from here, which is 2 over 7. So we can convert this to an improper fraction. So this is 4 times 5, 20 plus 3, 23 over 4 plus 2 over 7. LCM is 28. Divide by 4 is 7 times 23, 161 plus 28 divided by 7 is 4. 4 times 2 is 8. So this is going to give us, this is 169 over 28. Note that we first work out the numerator before we move on to the denominator. So this is the value we've gotten from the numerator. Now we can proceed on to the denominator. And the denominator is only one value. Therefore, we shall just say we are at 161 over 28. Then this means divide by. So divided by our numerator, we can change it to an improper fraction so that it's going to be 4 times 3 is 12 plus 1, 13. So divided by 13 over 4. So this is 169 over 28 times 4 over 13. By 4, 1. By 4, 7. By 13, 1. By 13, 13. So this is going to be equal to 13 over 7. Convert it to a mixed fraction. It will be 1. Because of 7, then it remains 6 over 7. That is the answer to our question. Now let's look at another example. Like this one we have here from a previous KCSE paper. So these questions are normally equal to 3 marks. And they are just easy marks for you to be able to obtain them. Now, let's use body mass in this case again. Body mass. Brackets is there. So we shall say 4 over 9 times, this is 5 times 2, 10 plus 2, 12. 12 over 5. By 3, 3. By 3, 4. This is going to be equal to 16 over 15. Then from there we move on to division. So it is 2 over 3 divided by 16 over 15. Now, Again, we change the sign to multiplication and change one of the fractions to become the reciprocal. We pick the reciprocal. So this is going to be 2 over 3 multiplied by 15 over 16. By 3, 1. By 3, 5. By 2, 1. By 2, 8. This is going to be equal to 5 over 8. Then we have an addition here. 3.5 plus 5 over 8. So we can convert this to an improper fraction, which is going to be equal to 2 times 3 is 6 plus 1, 7. 7 over 2 plus 5 over 8. LCM of 8 and 2 is 8. Divide by 2, 4 times 7, 28. Plus 8 divided by 8, 1 times 5, 5. 28 plus 5, it's going to be 33 over 8. Now, before we convert it to a mixed fraction, we have a division here whereby we are dividing by the denominator. So we can convert instead the denominator to a improper fraction. So 8 times 2, 16, 17, 18, 19 over 8. So this now is going to be 33 over 8 divided by 19 over 8. So it is like 33 over 8 times 8 over 19. These two go. So that we remain with 33 over 19 as our final answer. Therefore, we can now convert it to a mixed fraction, which is going to be 1. 33 minus 19. 14 over 19. The answer is going to be 114 over 19. So those are 2 examples involving body mass, and we have so many questions in textbooks, past papers involving fractions, so you can practice as much as possible to be able to understand, because it is rarely misses in an exam. And those are like 3 free marks. As long as you know how to apply body mass, you are good to go. Now, we are done with body mass. We move on to the next subtopic, which now is the last one for the day, called standard form. Subtopic we call standard form. Now, a number is said to be written in standard form if it is written in the form k times n power n. K times 10 power n. That is the way we write numbers into standard form. Now, for example, if you have a number like 58000 and you are required to write this number in standard form, then you rewrite it by placing a decimal point after the first digit. For example, this now will be 5.8. No need to write these zeros in this case because they are not significant. The moment there is a decimal here, these zeros will not have any impact as long as we multiply by 10 to power. How many decimal places did we move? You see, if the number is 58,000, the decimal point is at the end here. So we moved how many steps to the left side in order to be able to place this decimal? We moved 1, 2, 3, 4. So we are going to raise 10 to power 4. So whenever you move steps to the left, then the power is going to be a positive power equivalent to the number of steps you moved. Now let's look at another example here. For example, 0.05642. And you are required to write this number in standard form. What do? You again place a 0 after the first digit, which is not a zero, a non-zero number. Non-zero number. In our case, it is 5. Therefore, we shall write 5.642. We must write all the other numbers because they are not zeros. Then multiplied by 10. Now, the power will be determined by the number of steps we moved. Now, check. We moved from this is where the decimal point was. We moved 1, 2, 3, 4, 5 steps. But because we moved 5 steps to the right, the power will be a negative power. So negative 5. So if you want to remember how to write the correct power, because sometimes students are confused whether to put a negative or a positive. Consider, if you moved steps to the right, the power will be a negative. If you moved steps from the decimal point to the left, right? If you moved steps to the right, yes, the power will be negative. And if you moved steps to the left, the power will be positive. Just that. That is how you can be able to remember. So standard forms are normally used mostly in subjects like physics, and maybe we can look at 2 more. So call this A, call this B, call this C. Look at a number like 49126. Write it in standard form. It's going to be equal to 4.9126. The decimal was at the end here because this number doesn't have actually. So we assume it is usually at the end of the number. So how many steps? 1, 2, 3, 4 decimal. So the power is 10 to power 4 because we moved to the left. Then another one. 0.02160. Write it in standard form. How are we going to go about it? We shall move steps to the right. How many? 1, 2 decimal. So it will be 2.16. Is this 0 significant? Is it relevant? No, it is not relevant because the power we are going to place there will take care of it. So our power is power 1, 2 to the right. So power 2, which is negative 2. And there we go. That is how we do our writing of standard form. So let's go back to our checklist. We have looked at proper fractions whereby the numerator is smaller than the denominator. We have looked at improper fractions whereby the denominator is less than the numerator. We have looked at mixed fractions whereby we have a whole number and a fraction. We have looked at equivalent fractions whereby we said if we multiply a fraction by the same number, both the numerator and denominator, we shall come up with another equivalent fraction. And if we divide, on the other hand, by the same number, both numerator and denominator, we will get another equivalent fraction. So that is how we can have equivalent fractions. Then under this, we also looked at how we can be able to arrange fractions in ascending order, which I have shown you. You get the LCM and you do like you are doing addition. That way you'll be able to get that particular fraction that corresponds to your original fractions under the same denominator, and that way you'll be able to do what? You'll be able to tell which one is bigger, which one is smaller. You can arrange them in ascending or descending order. We have looked at recurring decimals. These are decimals which have some numbers which repeat themselves, and we have been able to see how they are written and how we can convert them to fractions. Then finally we have looked at body mass. some two examples of body mass, a question that rarely misses in an exam, especially the national exam. So put more emphasis on it. Then we have standard form, our last part, which is what we have just completed. Hope you've understood something. Thank you so much for your cooperation. It's a pleasure to have you listen to my lessons. Please comment, subscribe, like, view. If you have a topic that disturbs you and you'd like me to tackle it and post it online, you are free to do so anytime, any day. Be blessed, and let's meet in the next lesson. Bye.